All right, so let's talk about rational functions. Now, in rational functions, just like in polynomials, step one still talks about end behavior. The difference is, in rational functions, we have three types of end behavior, and it's all dependent on the degree of the numerator and the degree of the denominator. So the degree of the numerator here is 2. The degree of the denominator is 3. So since the degree of the numerator is less than the degree of the denominator, we are in type, here we go, I can't write, type 1. This means we have a horizontal asymptote at y equals 0. So let me put that over here and make it blue. Y equals 0. Okay. Everything else from here on out is the same for all rational functions. The only thing that really changes is the end behavior. So step 2, we set the denominator equal to 0 and solve for x. So our denominator is x cubed minus x squared minus 24x minus 36. We're going to have to do synthetic division on this guy, right? So if you set this equal to 0 to solve for x, we're going to need to know what are our p's and q's. Well, q is nice, it's just 1. So we have plus or minus 1 for those factors. But our p is 36. So the factors of 36, well, we obviously can divide it by 1. It's divisible by 2. It's divisible by 3. It's divisible by 4. 6 times 6 is 36. 9 times 4. 12 times 3. 18 times 2. And 1 times 36. So let's start this on a new page here. Let's do our synthetic division. Okay, so what was our function? Our function was f of x equals x cubed minus x squared minus 24. Let's make that actually look like a 2. 24x minus 36. So let's start with number 1. Got a 1, negative 1, negative 24, negative 36. Okay. Bring the 1 down. 1 times 1 is 1. 1 plus negative 1 is 0. 1 times 0 is 0. Negative 24. 1 times negative 24 is not going to work. Try negative 1. 1, negative 1, negative 24, negative 36. Bring the 1 down. 1 times negative 1 is negative 1. Negative 2. Negative 1 times negative 2 is 2. Negative 2, 22. Okay, negative 1 times negative 22 is 22, but we're still not going to get there. All right, let's try 2. 1, negative 1, negative 24, negative 30, negative 36. All right, bring the 1 down. 1 times 2 is 2. 2 minus 1 is 1. 2 times 1 is 2. 24, negative 24 plus 2 is negative 22. Still not getting there. Okay, let's make that looks like a 6. Let's try negative 2. 1, negative 1, negative 24. Come on, negative sign. Negative 36. All right, bring the 1 down. Negative 2 times 1 is negative 2. Negative 2 plus negative 1 is negative 3. Ooh, this is looking good. 3 times 2 is 6, so we end up with a 6 here. 24 minus 6 is negative 18. Negative 18 times negative 2 is 36, and we're happy. All right, so now we can rewrite this function as x plus, right, because we changed the sign here, 2 times x squared minus 3x minus 18. We can take that one step further, right, because we can factor x squared plus x squared minus 3x minus 18. We know that 6 times 3 is 18. We know that this needs to be negative so that this one's negative, makes this one positive. So now we can go back to the previous page, and we can say our denominator looks like x plus 2 times x plus 3 times x minus 6. So those are our vertical asymptotes, right? That's what you do. This is how you get your vertical asymptotes. Come on, ASYM. Uh-oh. Well, we know for sure that we can rewrite this numerator as x plus 2 times x minus 2, right? We have a common factor. That means, let's put it in red so we remember, we have a whole at x equals negative 2. So our new function looks like factor, come on, looks like x minus 2 divided by x plus 3 times x minus 6. So when we evaluate our new function at negative 2, we get negative 2 minus 2 divided by negative 2 plus 3 times negative 2 minus 6. So we end up with a negative 4 on the top, and then negative 1 times negative 8 on the bottom, which is negative 1/2. So that means we have a whole at negative 2, negative 1/2. Now we can still go back and put our other asymptotes in, right? Because when we set this equal to 0, we get an asymptote at negative. At x equals, come on, x equals negative 3. And one at 1, 2, 3, 4, 5. X equals 6, right? Let's go back. Next step, come on, turn colors, there we go. So, step 3, right? We set the numerator equal to 0 and solve. Well, that's pretty nice, right? Because the numerator is now just x minus 2 equals 0. So x must equal 2. So we have a vertical, we have not a vertical asymptote. We have an x-intercept at x equals 2. Now remember, there's a second little step there, right, where we can always say the y-intercept is a ratio, when x equals 0, we get a ratio of the constants. So negative 4 over negative 36, so that's about 1/9, right? So we had a 1 here at positive 2, 0, and we have we have a point at 0, 1, 9. All right. Last step is our sign chart. So in order to do this, I'm going to do a little bit of erasing. You can always rewind this, and we can see where I started out. I'm just going to erase that part here, the typing, so that we can get our last step in. So since technically y-intercepts were step 4, our last step is the sign chart. Why not? Let's leave it green. Step 4, sign chart. This is where you collect all of information you have gleaned from steps 2 and 3. So we know there are three x's that we're interested in. We're interested in x equals -3, x equals 2, and x equals 6. So -3, 2, and 6. And our factors are these guys here. X minus 2, x plus, come on, I don't want you to hear, come on. X plus 3 and x minus 6. So when x minus 2 equals 0, x equals 2. So to the left is negative, to the right is positive. When x plus 3 equals 0, x equals -3. So to the left is negative, to the right is positive. And finally, when x minus 6 equals 0, to the left negative, to the right positive. So when we look at this, we end up with a negative, 3 negatives. 2 negatives make a positive, 2 positive and negative, that's negative, and 3 positives. So what this means is, for x, when x is less than -3, our function is below the x-axis. When x is between -3 and 2, so in between here, our function is positive. So we're going to go up like this. Remember, you cannot cross the vertical asymptotes. You can cross the horizontal asymptotes in the middle. Between 2 and 6, our function is negative. And when 6 is greater than 6, it's positive. Now wait a minute, our whole is messed up, isn't it? At -2, at -2, -4, -2 plus 3 is -1. What happened here? Oh, this should be positive, shouldn't it? So this guy should be positive, which means this hole should be right here, not down here. See, even professors make mistakes. So let's erase this. And we erase the middle part of that. Now let's put our hole where it belongs. Let's make it red so that we keep things consistent. So see, I made a mistake. Our hole is here at positive 1/2. So at -2, 1/2. We have a hole. All right. So there is the real time, even with mistakes and corrections. Here is our beautiful rational function. Good job.